Alright, welcome back to the Verilog tutorial. This is the second part. And we're going to pick up right where we left off. What I'm going to do is I'm going to elaborate more on what we did in part 1 to help bring about some clarity. And then I'm going to explain what we will do to expand the device into a 2-bit full adder. And then we're going to implement it in Verilog. And there are a couple important things that we need to remember from the last part. So if you're just jumping in here, I would recommend going back to the last part and at least touching on these concepts. We used a for loop in our test bench to perform exhaustive testing, and we also connected the module ports for our device by name as opposed to doing it by order. And I'm going to be using these going forward, so it's important that you understand why I did this and how I did this. So here's where we left off, and I'm not actually on the remote desktop right now, but I've got an image of the code that I wrote for the previous part of this tutorial, and this is the 1-bit full adder. And to your right is the black box representation of the device. So on our right, the generic black box represents at a very high level what we are trying to achieve. And what we've got here in our Verilog code is the actual internal workings. So this is actually what's inside of the black box. And what's inside of the black box looks like the circuit schematic that you now see on your right. And what I've done is I've labeled these wires to correspond with the wire variables we've declared in this code. And of course the inputs and the outputs also correspond to what we've used in the code. Okay, so here we are back at the remote desktop. I'm in the project that I started in the previous part of this tutorial, and I'm looking at the 1-bit full adder module. I'm going to take this module now and use it to build a 2-bit full adder. And the way I'm going to do that is I'm going to go to the editor menu and create a new HDL file. I'm going to call this module TBFA for 2-bit full adder, something nice and short. I'm going to use the same labels for the ports, so A, B, C, I, S, C, O. Declare my inputs and outputs. And now my inputs are 2 bits wide for A and B. But carry in is still 1 bit. Output for the sum is also 2 bits wide now. And the output for carry out is still the same. So maybe let me put some notes next to the inputs and outputs. Okay, so now I need to instantiate the full adder twice. And so we're going to add the lowest bits of A and B together first. And that's going to produce the lowest bit of the sum. And actually, I need to declare a wire here that I forgot about, that I'm going to need to connect the full adders. And so the carry out of full adder 1 is going to end up becoming the carry in for full adder 2. So now we're going to add the most significant bits for A and B. And so the carry in here, notice, is wire 1. And this is going to produce the most significant bit of the sum. And carry out will go to our output for carry out. And that's the end of the module. So we're going to save this. 2-bit full adder. And then we need to create a test bench for it. So create another HDL file. So we're going to need some registers for our inputs. So reg, and they're going to be 2 bits wide. So this is going to be for A and B. We're going to have a reg for carry in. We'll call these our inputs. Our outputs are going to be on wires. One's going to be for the sum. It's also going to be 2 bits wide, and one's going to be for carry out. And we're going to need some integers for our loop variables. I'm going to use some nested for loops, and I'm going to need 3 counters to do that. And I need to instantiate my device. And so it's 2-bit full adder, and I'm connecting the ports now. And so now we're going to begin testing some values. So this is our first for loop, and this is going to be for the carry-in value, which will go from 0 to 2, or 1 actually. It's just going to be 0 and 1 because it's a 1-bit value, so it can only take on the values 0 and 1. So we're going to make this for loop iterate over 0 and 1. Oops. That's 100. And so now I'm creating a nested for loop here, and this will be for value A. A is 2 bits wide, so we'll iterate from 0 to 3. And another nested for loop. Now there is a way to do this with just one for loop, and it's actually really easy and straightforward. However, I wanted to show an example of some nested for loops, which is why I'm doing it this way. Oh, we need an instantiation name up here. This would cause a compiler error. I forgot about that. Oh, and we need to save it too, so we'll call it test2bit. And we're going to finish up now. And so that should be it. That's the end of our test bench. Okay, so now we need to add the files to the user source files for the project. And once we're done with that, we can simulate. And this will take a second, and I want to mention briefly here that I'm not going to verify all the results. I'm just going to give them a quick look over. That is something that I would recommend that you would do on your own, is to verify that everything's kosher. And ignore everything on the timing diagram right now. That's old stuff that I did when I was testing this code. The important stuff will appear in just a moment. There it is. So let's look at some of these. Does it look alright? So now let's take a moment to review what we've done. So what I have here is I have a picture of the code for the 2-bit full adder that we wrote in this tutorial, and to the right is the black box, which is the visualization of the device that we've created. And notice how A and B both have a 2 with a dash or a / through the input. That basically just means that both of them are 2 bits, and the same thing for the sum, or S. So at a high level, this is what we've created in Verilog. But now I'm going to show you a picture that will help you internalize maybe a little bit more what we've done. And so to your right now, there are 2 1-bit full adders, and each one of them has the respective instantiation name. And notice how in full adder 0, the first bit of A and B are input along with carry in, just as we've labeled here in, or as we've done here in Verilog. And this produces the first bit of the sum. And whatever carryout is produced is hooked up to wire 1, and wire 1 goes into the carry in of full adder 1. And the second bits for A and B are added together, and whatever carryout is produced here goes to carryout. And so this is what we've done. This is what the internal workings now look like for the black box that we have for the 2-bit full adder. And if we wanted to go further, we would see that each one of these full adders has the 1-bit full adder circuit schematic that we touched on in the beginning of this portion of the tutorial. And so we've kind of created this layered design. We've worked from the bottom up. And that's going to conclude this tutorial.